First we're going to draw up the beam, 150 mils high and 100 millimeters wide, 10 millimeter thickness. And I'm going to cheat a little bit by doing the mirror and mirroring the body twice, well, mirroring the sketch twice actually. Delete that one. By the way, I'm fast forwarding a bit here, I'm not quite this quick on the mouse. Not this time of night anyway. Right, so there's our cross section. Just double check, yeah, that is 150. And extrude that about 500 millimeters. Okay, that's our inventor model. Now we're going to do the stress analysis. Hitting the stress analysis tab. Just say OK for stress. I'm just going to go back to shaded. Right. Now, assigning steel is our usual material. So just go into the override material, steel, just the ordinary steel there. And okay, that sets the densities and the stress properties of the material. Next job is the constraint. We're going to use a fixed constraint on the end. This is a cantilever. And so when we rotate, now just the thing about gravity, we're not going to set gravity here, we're leaving gravity off, which means we're not taking the weight of the beam into account. Now we're going to set a force on the free end of the cantilever, setting the direction of that force by hitting the direction arrow first. There we go. And now we pick a line to align that arrow with and reverse the direction. 25 kilonewtons is the force applied over the entire free face of the cantilever. Just changing the arrow there to make it a bit bigger. Okay, now that's our forces set up. Just checking the mesh, see what it looks like. Looks about pretty normal. And now we're going to do the simulation. Okay, Inventor runs the FEA simulation, and there we have, the standard thing is von Mises stress, but we want our shear stress here, and the shear stress in our plane is in the YZ plane. And so the YZ plane is telling us the shear in the web. Sometimes you have a problem with the probe. You just go up, hit the probe button and then click, but then sometimes you have trouble selecting that probe text box because what's happening is Inventor keeps selecting the body underneath. So you have to spin the job around until you can get a free place to pick up that tab. There we are. Yeah, it is a bit annoying, but that's the explanation. If you can't select the probe dialog, it's because it's being pre-selecting the body instead. So you have to spin the job around until, or zoom it. Zoom actually works quite well to pick it up. Alright, now once we do pick it up, there we go, that should work. You can right click on that, edit position, and set the exact position that you want to measure the stress. Very handy thing this. So I want to be right in the center of the object and maybe about a certain distance along. That's 200 mils. 200 mils is on the other end, so we're measuring from the free end. Depends which end I put my constraint on, so let me get up closer to the wall. I'll set that at about 400. Right, so there I am. Now I didn't go all the way to the wall because the wall is mucking up the shear stress in the web, and the reason for that is the fixed constraint is very is pretty unusual. It allows absolutely no flexibility whatsoever. So yeah, we got 18.6 there in our hand calculations, and here we're getting 18.7, so that's pretty good. At 30 mils above the neutral plane. Alright, that's it. See ya.